So let me first get the answers. We got 1 root at -3, right? We got 1 root at -1. We can see that on the graph. Are you on slide 5? Yeah?
Yes.
So they're monomial forms. You need to get used to that by seeing the graph. That's how you're going to know how to do this whole thing. That's what's going to make it easy. So one of the monomials is x plus 3. The other monomial is going to be x minus 1, and the other one's going to be, sorry, x plus 1, and the other one's going to be x minus 2, right? So then we should wind up with the factored form for this factoring this. The factored form should be this. The opposite of the roots, right? Now, does that make sense visually? Because that's where this is 0. It's going to be at the roots, right? Okay. So then, in order to factor this, you put one of the monomials underneath it and you do long division, right? Let's see what happens if we do the wrong one. What if we do x minus 3 by mistake, right? It's not really a mistake. You would guess maybe one of them is minus, right? So then, first off, you've done long division before, correct? So let's do it again. So we start with x squared because we want these two to cancel. We get this and we get -3, and then these will add to 5x squared. Then we drop it like normal division and we guess another. So we need that 5x to cancel, that negative. So we need to put a negative 5x. We want that to cancel. So, oh, I'm sorry. Hold on. My apologies. The zero's in the way here. Your answer, you need to put it like this. Be careful of that. You don't need to put 0 when you're doing division. It's just understood because that's what you're trying to get. So we need to cancel those. So I'm going to guess a 5x squared. My apologies. 5x. Because I need that to be a 5x squared. So then I do it again. Let me change colors. That's what's kind of throwing me off. So if I do this one, I multiply that, I get the 5x squared, and they should cancel. That's how you know. You do the other one, and you get the negative 15x. That becomes 10x. You drop the -6, and then we keep guessing. So we need this to cancel now. Now try that one. So I need that to be a 10, so a 10 here. It needs to be 10x, so you get the 10x. You get the -3. It's -30. Now, did we get a remainder of 0 when we finish this? We didn't, right? You with me?
Mm-hmm.
So if we don't get 0, we're wrong. We haven't factored it. Now let's try something. If we're right, let's see what it looks like. You know, a big thing about learning with me is not guessing, right? So let's guess from our roots above, one of the guesses we can use is a -3. That makes the monomial x plus 3. That's one of the answers, by the way, one of the factors. So I put an x plus 3 here. So then what's my first guess? What goes in this box?
X.
Because I need that to be an x cubed. It needs to be what? An x squared, right?
Yeah.
Jolly good. Okay, so if I do that, that becomes an x cubed, right? Do you follow?
Yeah.
And then that becomes...
3x cubed.
You mean 3x squared?
Yeah, 3x squared, excuse me.
Good. That makes that a negative x squared. We drop this. Put our minus sign again. and we repeat this, right? So what's my next term I should guess? Let's clean this up.
In order to get negative 2x, you need to get, yeah, you multiply with negative x.
We need this to be a negative x, correct. Good job. That gives us a negative x squared here. There's always that understood minus when we're doing the algorithm, right? You know that from traditional division. And then we multiply the negative x and 3. That makes that a negative 5, and that's going to be a negative 2x. This term should always be 0, right? That's what we're getting at. That's why it works. We drop that, and then we make our next guess. So we need this.
It has to be negative 2.
Very good.
I understand it, but among all the methods, long division is what I understand how you factor this out.
Very good. Guess what? This is 0. Guess what we just did?
So how did you get the x plus 3 again?
You go up you look at the last term and the first term. And then what you do is you use this form, or one of them, right? And you always take the last term coefficient over the first term coefficient. But you have to find all the multiples. You got to do a factor tree. Factor tree for the last one being 6, 1, 2, 3, 6, and then the factor tree for 1, which is just 1. And these are all the possible factors.
Wait, so like the factor tree 1, 2, 3, 6. So, wait. Oh, so you do the factor tree of 6. So
that's right. You know, the good thing is that when you do that factor tree, sometimes it's just the top one.
1, 2, yeah, 1 times 6, 2 times 3, 6.
And that's going to be what. Good job. Yeah, and that's what you're going to be roots. That's what your roots are going to be equal to. But you have to, if you're going to do
wait, sorry. Since you're finding out what is. Oh yeah, because yeah. Because like, so because A is 1, yeah, because yeah.
Clicking. I love that. I love that.
Because yeah, it matches. So yeah. Oh, so it's kind of like standard form, but it's just like there's a X next to C.
Yeah, you just kind of add the letters as you go along. Yeah, and I always start with A. Yeah, absolutely. Good job. You're smart guy.
Yeah, and then what you did was that since once you find all the possible factors,
you guess one of them because there will be no other factors out of this lift. Is if it indeed is not complex in factors, sometimes even complex, but yeah, even complex. They have to be. These are the all possible factors. There's no other number out of this that it's going to be your factors. That's the beauty of this method.
Oh yeah, because you can just because you have multiple guesses right there. You just find out the guesses. You just have to plug each one of them to see if it works. If it doesn't work, then you. Yeah. But the thing is, how do you know if you were to get it on the first try though? How would you know that?
Then your remainder has to be 0.
Yeah, I know that. But the thing is that let's say like 1, 2, 3, 6, and 1. I mean, how did you know that you wanted to do x plus 3?
I just guessed it. You guess them because the beautiful thing in this method, you said it. The factors are only going to be in that list, so you only have 8 guesses to try, and oftentimes you'll get it in the first guess, the first 2 or 3 guesses even. It rarely happens that it's going to be your 4th guess.
Can I practice one like this?
Absolutely, but can I show you the finish this real quick? This one. So we got a remainder of 0, right? I guessed I divided by x plus 3 into the polynomial that was given. The quotient is what's left over, right? So we've partially factored this. If you multiply x plus 3 on both sides, then by way of abstract, you've got this now. Look, you've got x plus 3 times your answer, which is your quotient, right? We call that a quotient, right? Of course. That's going to be your answer up here. Now guess what? We can use any method to factor the rest of it. If you look at that right there, I bet you it's going to be x minus 2, x plus 1.
My x, yeah. Wait.
It's beautiful how quick you're getting this.
Yeah.
So let's say that you have the polynomial, since we already know it really, you've got x squared minus x minus 2. So what's your possible, then we do c over a, right?
Mm-hmm.
Right? You tell me where to go from here.
Hang on. Oh, you're on the next slide.
Yeah, you're good. I'm sorry, I forgot to say it.
Yeah. It's purpose. Did you... Is that it? Oh, okay. We're doing the long division method, right?
Right. Now, we can...
Okay,
we could factor it, or we can just do the long division method on this by guessing a factor.
I like the guessing long division factor. That's fun, and that's way more efficient.
I know. I bet your brother would go ham on this.
My brother already knows that method. He just
I bet he would. I bet he'd be like, man, this is the best way.
Yeah. So anyway, -2. That's gonna be.
You can just guess positive because remember, it can be any plus or minus of those guesses.
Yes. So it's just gonna be 1 and 2.
That's right. And the first term a was 1, right? Now the reason we put the first term is it can also be a fraction. Had a been like 5 or something, we'd have to put that, it could be 2 over 5 as one of the roots, right? It'd be minus 2 over 5. Because you also have the possibility of their fractions. That's why we do it. But in this case, we keep it simple. So you tell me, and we need to do root form when we do this, what's one of the roots you're guessing? 1 or 2?
I would say
-1, -2?
2.
2? Okay. 2 or -2? Which one do you think? Let's do 2. Let's do 2.
Yeah.
Let's get rid of that 5. Let's do 2. Because what if it's not right? I'm going to show you how fast it goes. So remember, we need this in what form?
X plus 2.
X minus 2, you mean, because x equals 2 is x minus 2 in its monomial form. Right?
So do we always have to do subtraction?
Yeah, because you need it in monomial form to do long division.
Okay.
Otherwise, you can't divide x equal 2 by x squared minus x minus 2 with long division. It has to be in monomial form. You can't divide an equal. You can't divide a point, right? So we have to put it in its monomial form. Right?
Okay.
Does that make sense? It wouldn't make sense to say x equals 2 divided. Have you ever had that? That's not real. You know what I mean?
Yeah.
Are you sure? Let me put it this way. Can you divide this by that?
No, you can't do x equals 2.
Right, so that's why we have to do it in its opposite reciprocal. So you
because the last time you did x plus 3, so that's all I'm asking.
Well, last time what I did was I started with a guess. My guess was x equals minus 3. I messed up with the positive 3. I didn't mess up. It was one of the guesses that didn't turn out right. But if I guess minus 3, it has to be x plus 3, right? Why is that? Look at the graph. If it's 0 at x minus 3, the factored form is x plus 3 because that's where that would give you 0. Right? If I plug in the minus 3 guess up here, if you look, then that would give me one of the zeros in that factored form, wouldn't it? Like I showed you the other day. Because you'd have 0 times all this stuff, but anything times 0, no matter how many things, gives you 0 for that point. So that's why you have to guess the opposite. You need that to be 0. After all, that's what we're doing. We're finding the zeros, and then you're doing that. We're using Colton's hack. We're using the zeros, we're putting them in monomial form to use long division to factor it. Yeah. So backtrack. I don't want to overload you, right?
Mm-hmm.
Let's backtrack. We have x squared minus x minus 2. We put our guesses. We set them equal, and then we do the opposite for the monomial because we are guessing the root, and then we're putting those in monomial factored form because we're trying to factor, right?
Mm-hmm.
We'll call that a monomial factor. So we need to know what this is. So you guess that, and you do your long division. You tell me what to do.
All right. So let me just. So you know you need to start with x.
Okay.
So x times x is x squared, and in order to get negative x.
Don't forget your minus 2 here.
Yeah. And we need it to equal yeah.
And so what is your adduct?
Yeah, so x squares cancel out, and negative x minus 2x is negative 3x.
Oh, negative x minus minus. We can't forget our algorithm minus.
Yeah.
So we got to distribute that, right?
But we never on the last one we never distributed it.
No, I have been. I have been doing that. You just weren't seeing that. You always always have to distribute. This is always okay. Let me explain. If you're dividing 5 by 3, right? That minus is always there when you're dividing. Makes sense?
Okay.
Let me do one simpler. We're using the same algorithm. That minus has always gone there for division, remember?
Yeah. So it's gonna be negative x squared.
You mean positive, yes, and x squared minus x squared is 0. We don't put the 0 because it messes things up. We just know it's 0. So we just leave that empty because that's what we're doing. It would be circuitous. So then we got negative 2x, but you got minus the 2x. What is that? Positive 2x, right? Positive 2x minus x is x, right?
Yeah.
Then we drop the negative 2.
Yeah.
Here, let me make it easier. I got ahead of myself. So you've got always that negative, right? Making that a positive 2x minus x. That gave us an x, right? Then we drop that minus 2. Just like in division.
Yeah, so
right? Good. Now we put the algorithm negative, don't we?
Yeah.
In parentheses. Now what? We need that.
Add another.
We need that to be an x, right?
Yeah.
Or a 1. Sorry. Is it a 1?
I mean, it says x minus 2, so if you do, I would say x.
Well, if it's x, we go back to x squared, and we're back up here.
Then do 1.
Right, because we needed to multiply times that to give that, right?
Yeah.
Your guess when you're doing this is always going to be 1 degree less. So then that gives me a negative 2, right? What's my answer?
0.
Guess what you just did? That question mark became x plus 1. That was your... Now we move it back over to prove it's in factored form by multiplying x minus 2 on both sides. You factored it. Now guess what? Earlier on, we had the whole polynomial was what? It was this, right?
Yeah.
That's right. That's where we started. I let you do the quadratic one, right? The easier one, right? So we can keep going with that process until we completely have factored that cubic. It's the only way to do it, really. It's the only real way to do it. Because you're not always going to get polynomials that have like, oh, it's a cubic difference of cubes, or it's a blah, blah, blah. This is algebra 2 now. Those formulas don't really work that well when you're dealing with polynomials. So what we have all together is this. Now we have that you just factored for us. You've got that this whole thing factored now is equal to this. What was it? X minus 2 times x plus 1, and we're done. Let's give you another one, shall we? Let me do something easier.